Nobody knows more about tools than Snap-on. And that includes storing, organizing, and protecting them. And nobody offers more tool storage product choices than Snap-on. Our KRA series offers a unique combination of performance and value. Hard-working, long-lasting tool storage units that make professional quality available to just about everyone. These are Snap-on quality throughout. And they're available in a selection of roll cabs, top chests, portable chests, side cabinets, drawer sections, end cabinets, workspace risers, and overhead storage units. It's all about value. The KRA series defines value as professional quality, wide selection, and affordability. Thousands of technicians return to Snap-on time and time again for their tool storage needs. That's what it is all about. At Snap-on, great tool storage starts with a great design. Our engineers use the latest computer technology along with our knowledge of the industry and input from dealers and customers to produce tool storage products for all segments of the automotive market. Only Class 1 steel is used for our boxes, just as it is in the automotive industry. Steel rolls in gauges from 16 to 24 arrive in rolls up to 10,000 pounds each. An average of 80,000 pounds of steel is used each day, with the entire inventory being turned every 5 to 6 days. The rolls of steel move to a variety of presses, with capabilities of up to 250 tons, and components from small brackets and spacers to large panels are produced. The inner panel of our roll cabs is punched with up to 80 different holes to provide our customers with flexibility in their drawer configurations. These components are checked regularly on a linear squaring table to ensure that exacting standards are maintained. Large presses with dedicated tooling allow complete panels such as this top chest bottom panel to be formed in one process. This ensures proper overall dimensions and squareness for ease of assembly and ensures smooth drawer function. A unique process in the KRA roll cab manufacturing is the design and production of the 18-gauge unibody outer panel. This one-piece roll cab design produces a stronger, more cost-effective product than welding individual panels. After the metal sheet is inserted onto the first station, it is advanced forward, where it is notched and punched before moving to the multi-head robotic spot welding station. The drawer lock assembly is then added and welded into position. The final step involves hemming and rolling the front edges of the roll cab and forming the panel to its final shape. The complete process, from sheet metal to final unibody shell, is completed in less than 40 seconds. Like this unibody outer panel forming machine, many of the manufacturing tools utilized at the plant were custom designed and built by Snap-on employees to ensure that the individual components would be produced exactly as originally designed. It also allows multiple operations, such as punching, welding, and forming, to be more efficiently completed than on separate machines. In addition to custom machinery, all stamping dies for the various panel designs are produced here at the plant. Once ground to specification, these high-strength steel dies are attached to a die plate, which has been drilled, countersunk, and tapped for the specific location of each die. This offers the flexibility to make changes and updates to panel configuration quickly and cost-effectively. Corner gussets are hidden components that add strength to our boxes, as well as maintaining squareness and rigidity. The top panels with the added corner gussets are then welded to the unibody outer wall of the box. This process is completed in a custom fixture that holds the components firmly to maintain a square structure. Full-length Z stiffeners are used between the inner and outer panels to prevent creases and to withstand side loads. These stiffeners are spot welded to the inner panels, which are inserted to the roll cab and welded in place. One-piece 16-gauge bottom panels for the roll cabs go through a series of procedures where carefully designed channels are formed into the panel for added strength and rigidity. Though time-consuming, these procedures produced a much stronger base for the roll cab than welding a stiffener to the bottom panel, such as some manufacturers do. Caster plates and weld nuts are utilized to provide a secure and long-lasting attachment point for the caster bolts. This ensures that the cabinet rolls straight and is able to absorb rough surfaces. The one-piece bottom panel is welded into the rest of the box with care taken to ensure that the spot welds are a maximum of 3 to 4 inches apart. This ensures that the box stays square and the panels do not warp. Extra welds are added to the corners of the box to offer additional support for the casters. After the bottom is in place, the inner panels are welded to the outer panels. This double wall construction provides strength and durability and ensures smooth and easy operation of even heavily loaded drawers. The last step prior to pre-treatment and painting is a final sanding and inspection to ensure that exterior surfaces are smooth and free of scratches. One of the innovations the Newmarket plant has utilized to great success is the concept of cellular manufacturing. Utilizing these cells allows an entire subassembly to be completed and passed down the line to be incorporated in the final product. In this drawer cell, the drawer blank is hemmed, the edges are folded, and the body takes its final shape. This cell was designed and built by the Snap-on employees here in Newmarket for this specific function and is capable of producing all the different drawer sizes included in the KRA line. 80% of the output from each cell is provided utilizing just-in-time techniques, where the product may enter the next step in production just minutes after being completed. Cellular manufacturing and just-in-time provide an extremely efficient and cost-effective way to increase productivity in the Newmarket plant. The drawer front design incorporates a teardrop shape that is extra deep for ease of use and is also very strong. Another advantage of the design is that it conceals the tools in the drawer when closed. The completed drawer fronts meet up with the drawer body and back in a 4-position robotic spot welder that maintains the squareness of the drawer as the components are joined together. The result is a consistently produced drawer that rolls smoothly whether loaded or empty. Lock tabs on our drawers are welded in place rather than formed into the drawer back, so even if a bank is locked, the drawer can be closed and locked automatically without damaging the drawer body. The forming process for the top chest panels involves a series of bends that strengthen the body of the top chest and allows the individual components to be spot welded together. This attention to design and construction helps eliminate any racking effect where the body could become out of square, affecting drawer function. Once the side and bottom panels of the chest are produced, they are mounted in an automated welding fixture which joins the components together. Note the handle backing plates that are attached to the side panels to support the handle when a loaded box is lifted. A smooth edge has been applied to the top edges of the side panels for safety. Consistent bends are produced in the back panel assembly by the use of front gauging. The operator holds the metal sheet against the steps in the guide to ensure accuracy and consistency. The back panel then moves to the main assembly line to be joined to the bottom and side assembly. Again, a dedicated fixture is used to hold the components in place. Copper backing plates are built into the fixture to minimize spot weld dents. The final step for this assembly prior to entering the paint line is to have the top of the chest welded in place. It will then be married to the lid at final assembly. On some top chests, a drop front is attached to the lid as well. Round edges are produced in the lid by a custom mandrel in a large press. End plates will be attached to the lid for a strong and secure lid assembly. Full-length piano hinges are used to allow the lid to move freely and easily. This also keeps the lid square to the box and prevents twisting. Some larger lids are supported by gas-assisted springs, which also provide smooth lid function. If a drop front panel is used, it is welded to the lid prior to the assembly entering the paint process. All sub-assemblies that have gone through the manufacturing process now enter the paint line. 2 separate conveyors transport the product to the e-coat and powder coat processes. A 9-step cleaning and pre-treatment process is applied to painting, which includes a phosphate coating and chrome sealer to enhance corrosion protection. The electro-deposition or e-coat process is controlled to ensure temperature, pressure, and flow rates are kept within specification. The complete pre-treatment and e-coat process is monitored 24 hours a day to ensure that no hazardous waste can enter the sewer system. After pre-treatment and drying, the components enter the e-coat tank, which contains 165,000 gallons of acrylic enamel paint. The line moves at 16 feet per minute, which allows a consistent film build, even on hidden surfaces. An electrical charge is applied, which ensures a very strong bond to the metal. The result is a high-luster, chemical-resistant finish that protects against peeling, blistering, scratches, and corrosion. The painted components then proceed to the drying ovens for a precisely monitored curing process. 3.5 hours and 3,800 feet later, the components are painted and ready for final assembly. A recent addition to the Newmarket plant is the powder coat line. As with the e-coat process, the components are washed, pre-treated, and dried prior to powder coating. The long conveyor allows time for the metal to cool to 100 degrees Fahrenheit, which is ideal for this process. The powder coat control panel monitors all aspects of the procedure. This includes temperature, pressure, flow rates, electrostatic charge, and line speed, any of which can shut down the line until the problem is corrected. The result of this attention to detail is a consistent paint finish, worthy of the Snap-on name. Powder coating with a high-quality polyurethane powder paint produces a durable, high-gloss finish and has the added flexibility of multiple color options. The movement of each of the guns is computer-controlled and specific to the actual dimensions of the part to be coated. All excess powder is reclaimed and reused to ensure virtually zero waste. Manual reinforcement is used for some parts due to the electrostatic effect of current trying to find ground. This ensures complete coverage, even in the corners. A completely separate powder coat module is used for each color, and the different modules can be interchanged quickly to minimize downtime. This flexibility provides exciting color options to customers who want to personalize their tool storage. The powder coating, once dull and gray, appears from the oven a shiny, high-gloss black. It has been baked at 400 degrees and is now allowed to cool on its way to final assembly. The e-coat and powder coat conveyor lines converge in the final assembly area. Here, the components are removed from the line and staged for final assembly. They will not have to wait long, as by the end of the next shift, many of these products will be in a truck and on their way to Snap-on warehouses all over the world. The key lock is one of the first items added to the roll cab as it progresses down the final assembly line. Ball-bearing drawer slides are then inserted in the box and the drawers are attached. The drawer slides have a capacity of 90 pounds per set, and an extra set can be added to drawers that are 4 inches tall or higher to double the capacity to 180 pounds. The customer can also change the configuration of the drawers to meet his specific storage needs. Once the drawers are installed, the lock and roll assemblies are inserted in each drawer and checked for function. This is an important feature that allows customers to safely roll their tool storage unit across an uneven floor without drawers drifting open. For top chests, the lid with its full-length hinge is attached to the top of the box and adjusted for a proper fit. In top chests with a drop front panel, the lock assembly includes a lock rod that is inserted into both of the side panels for added security. Large casters are securely attached to the roll cabs utilizing the caster weld nuts. The casters allow exceptional mobility and load carrying over varying surfaces while being resistant to the damaging effects of gas, oil, and solvents. After the assembly process is complete, every box is covered in a plastic protective sheet, an inner cardboard liner, and a rugged cardboard outer box to protect the unit in transport. From custom-built forming machines to multi-head robotic welding units to the e-coat and powder coat paint lines, there's a lot of high-tech engineering designed into each KRA tool storage unit. But these are not mass-produced boxes. They're assembled by highly trained machinists, welders, and assemblers for a tool storage unit considered by professionals to be the best in the world. Your customers have tools to store, tools that they value, tools that help them earn a living. These are a few of the reasons that professional technicians depend on Snap-on for their tool storage needs. The best quality, performance, and value in storage. We've got what it takes.